Hello and welcome to the tutorial Unity, MetaMask and Smart Contracts. In this tutorial I want to show you how you can deploy a game in Unity Web 3 to use MetaMask, that the player have unique wallet address to log in, use unique ERC721 NFTs to log in inside the game, and have multiple NFTs that you can use as items, armor, or just to show them up inside the game. You have your own coin that you can use to buy an NFT. Now the blockchain creates the NFT, and after the creation is finished, we load the game again and have a new NFT that we can use to play inside our game. We also can upgrade the NFTs. We can choose NFTs, select them, and can use the upgrade function. Now we burn two NFTs and create a new one. I don't have implemented a level system, but it's easy to implement a level system. Now the creation is finished and we load the game again. And we see we have a new NFT. If we go and look now to the contract address on the Binance Smart Chain testnet, we see that we created a new NFT and we have a transactions. Few minutes ago, where we created the new NFTs. If we look off from the side, and change the account, and now log in with the other account, we see we have no coins and no NFTs. So we have no player to log inside the game. So let's start the tutorial. Before we can start deploying the smart contract, we should declare the functions that we're gonna need inside the game that communicate with the blockchain. In our case, I took an ERC20 coin. Player can use this coin inside the game to buy NFTs, different NFTs, unique or multiple NFTs. Also, the player should be logged in the game with his wallet address. This we can achieve with MetaMask. And also we need the functions that we can store metadata URLs on the web server if the player click inside the game to buy an NFT. Before we can start writing our own smart contracts, we need a compiler for it, and I recommend Visual Studio Code. If you have downloaded Visual Studio Code, you have inside Visual Studio Code plugins and install Ethereum Remixed plugin and the Solidity plugin. After you have installed these two plugins, go to your directory. I have the tutorial directory and I have my 3 contracts, but for a new one, just click new file and write the name of the coin or smart contract you want to have with .sol at the end. If you have created an ERC20, ERC21 and ERC1155 sol file, we go to wizard.openzeppelin.com to get a new fresh created smart contract from the OpenZeppelin platform. At wizard.openzeppelin.com we can create new ERC20, ERC721 and ERC1155 contracts that has the normal standards for the smart contracts creations. In our case, we can use this, but we don't deploy it here. We just use this, copy paste it, and paste it in our new created contracts. After we pasted every contract we want to create to our Visual Studio Code files, we have to add some functions that we can use inside our game. So I created the function URI that defines the base URI, our NFT folders, and the metadata JSON file that we create, or that is created every time when we create a new NFT in our game. Because this is the contract for the multiple NFTs, I created 3 constant variables. One is just the logo. The second one is the blue panda shirt and the panda with the red shirt. These NFTs will all every time have the same token ID number 1 and token ID number 2. Then we need the function security address that only the address from this security address is able to interact with this smart contract. Why? Because we have this function that we can add ERC, but this function does not need money to get executed. So the only reason why it's only executed when we want to have it is to use the require message sender is equal to our security address, and we can set the security address. That means that only our security address is able to call this function, and this function is only executed when this security address is calling it. So we have 2 NFTs that we want to sell or that we want to use inside our game. So we have 2 functions, one function for the one NFT and the other function for the other NFT. It's possible to change this function, that you have only one function called, and in this function you define which subparameter takes another if statement. But for this case in the tutorial, I think we only need the small functions. So that means we added these 4 functions to the ERC1155 contract that we can interact inside our game with the smart contract. In the ERC721 contract, we have to add the security address too, that only the game coin address is able to call the add functions and the upgrade function. In the add function, we mint new NFTs for the player if they pay with the game coin, and with the upgrade function, only the owner of the NFTs is able to upgrade and burn the NFTs. After he burned the NFTs, we mint the new NFT for the player. And that's why we need the security addresses here too, that is the 2 functions are only be called from our game contract. Then we have to add another function, get all NFTs. With this function, we are able to call inside the game a EVM call to the blockchain, that we can get the latest token ID from the player to create the URI data and the game data for the game, and for the blockchain that the NFT can be used inside the game. In the ERC20 contract, we have to add some more lines because we want the ERC20 coin contract to be able to communicate with the NFT contract that we just write it. So in my case, I use the folder tutorial, and inside the folder, I have created this tutorial sol files. That's why I have to import my folder file. This can be your name from the game, this can be every name, but it has to be in the exact same order because the smart contract needs to get this file when we want to deploy it later. And after you have deployed it, you want to be able to call these files again to interact with your smart contract that you have deployed. Then we have to add the lines that the contract is able to communicate with the contract. The contract address you will get later if we deploy the contract. Then we deploy first the NFT contracts, come back, add the addresses, and after we deploy the ERC20 contract. The game address here is a wallet address I have added to collect the coins that players spend to buy NFTs. This can be a reward wallet, this can be your own wallet, this can be everything. And I have added some prices for the NFTs. Then inside the contract, we have the tutorial coin, and I know I call it ERC20, that you can see in MetaMask with ERC20, this your ERC20 coin. Then I built, excuse me. Then I built the function upgrade. In upgrade, we send to the smart contract the token IDs we want to have to upgrade, the amount, and the sender. If the amount is equal to the price we set here, the first rule is checked, and the second rule is that the sender to is the game address. That means everyone can call this function in the internet. But if someone else calls this function, then nothing will be happening. The money goes to the game wallet or to some other wallets or what they have defined. But if they want to mint an NFT in our game, they have to exactly fill these two orders. And then we can execute the upgrade function in the ERC721 contract that we have generated here. And with the normal transfer function, this is the function that allows you to see the amount of money that you transfer to the game. And if the player click buy inside the game, like I did before, you see MetaMask shows you the amount of coins that you want to send. For this you need this transfer function. This is the normal function. And I added these lines with the same requirement states. If the game address call the function and the amount is equal to the prices I set here, the function add ERC721, this means we mint a new NFT and send it to the sender's address. And if the price goes higher in the same amount like I said here, it's 200 coins, then we mint an ERC1155 with the token ID I said before, 1, that means it's automatically a bundle with blue shirt, and send it to the sender's address. The same is with the second ERC1155. You can, with the multiple ERC1155, you can have, so you can have 20, 30 different monies, amounts, and items, what you want. And the same is with the NFT 721. You can have difference. You can add multiple coin prices and multiple functions. But with these functions, you'll be able to interact inside the game with the blockchain. For this, we have to deploy the smart contracts, and this is the next step in the tutorial. So we go down to Ethereum Remix, and in my case, I'm connected with the Remix. Normally it's red, then you click, then you have here start, like here, start. After you started, you go to the website remixethereum.org, and you normally be connected with the default workspace. You can interact with smart contracts in the default workspace, but if you do this and you have to refresh your browser one time, every data is lost. So to avoid this, we want to connect with the local host, so that we use the soul file from our desktop, that we can call it every time we want to interact with the smart contracts later. So after the contract is loaded, we go to the second button for the compiler, click of compile, and if we have no errors, the compiler is okay and says everything is alright. Then we go to the deploy section, choose interject web3. This means that you are connected with MetaMask and using your actual MetaMask wallet address to connect with the blockchain network. In my case, I use the Binance Smart Chain testnet network. This can every network be that you are connected with the MetaMask, and then you deploy this contract to this network. For BNB Smart Chain testnet, you can get free BNB. Every 24 hours, you can get 1 BNB for free, because deploying a smart contract or interact with the smart contract will cost some BNB coins. Then you be sure that you click the right soul file that you want to deploy, and then you just click deploy. After you click deploy, you will see a new Windows pop up from MetaMask and ask you to pay an amount of BNB to deploy the contract to the blockchain. After this is done, you will see here your contracts. So now we deploy both contracts, ERC1155 and ERC721. Be sure that both of them are compiled, and after then compiling, the right file are deployed. After this is done, you will see that you have your file name and these addresses. Now we go to our ERC20 contract and copy paste this address here. So we say ERC721, we copy, double click, and we see, for me it's the same address. same address, and for you it's the new address that's generated during the blockchain deployment. After we set these two addresses, we are able to debug the ERC20, compile. After the ERC20 is compiled, be sure that to deploy the ERC20. Attention, you have set and imported two other contracts. That's why in this list you have the other contracts too. Be sure that you click the ERC20 contract. After you deployed it, you will get your ERC20 contract address. And with this ERC20 contract address, we set the first interaction with the smart contract and set our security address to our coin smart contract address. If we click, this can be done every time we see that the MetaMask pops up, we interact, we pay, and we see that this transaction is finished after a few seconds. Then we can call the balance of some player. I have here my MetaMask address. Then we see, I have 3 NFTs, and the function get all NFTs will get us all NFTs and the ID, token ID from the NFTs I have with my contract. So after we set the security address for the ERC21, we have to set the security address for the ERC1155 too. After the security address is set, we can now test if we add an NFT, if we use the transfer function, use the address where you want to receive, in this case my address, want to receive. What I want to receive is a new NFT, fill in the amount and use transact. I don't do this now because I have in-game my URI metadata set it. That means if I create now an NFT, the game doesn't know that this NFT is born or is minted, because only the URI metadata, if I mint the NFT now, this will not set any information in the URI data. This must be done inside the game or via Web3 or some other applications that write to a server that metadata. But if in your cases where you don't not have implemented the Unity code, you can add the amount here and mint some new NFTs. I will show you now how you code Unity to interact with the smart contracts. Web3 from Unity is a free open source data library that can everyone download. And I created this tutorial package that everyone can download and use to see how to interact. So inside from Unity, it's important to know if you use the Web3 implementation, you have a login script on the first scene. And if you want to load the game from this scene, this should only be able in the Web3. That's why it's good that you take a second web dev login where you set your MetaMask address where you want to interact with the game and delete the stuff that you need to log in. So if you're just deploying and you know you don't go to the web server, just use the web dev login on the login script, change this to web login dev, and then you'll be able to log in with this scene. Otherwise, you have to go to the loading screen, and if you have no address set, the loading screen is not able to load something from the blockchain because there is no information to load. So this is just important for developing. Now we go to the scripts and go to the first script that gets the balance from the player from the blockchain. So I will do this a little bit bigger. So you have to set your coin address that we created, and that we see from the remix, where we can copy address and paste these addresses. So we go here and copy this address from the coin. Then we know this is the ERC20 coin that we need. And the coin address for the 1155 ERC. Then here I know that I use Binance and I use the test work. So now we set everything in the file that we need. What does this file do? This file starts a loading screen, call the blockchain, the balance from the player. The real balance of a ERC20 coin is always amount with the decimal. That's why we submit that we have the real balance of the player. With the balance of the NFTs, we don't have to really do something. We just get the balance and save it as a player breath. After the game is finished, we delete all player breaths. But during the session in the game, we need the player breaths to hold the balances from the players. Then we get all token IDs. That means we get a list of all token IDs that the player has on the blockchain saved. The same we do with the balance of the token ID 1, because the player can have more NFTs. So we know that's the token ID 1, but we want to know the amount of the number 1. That's why we need for every multiple NFT the own function of the balance. So in my case, I have 2 functions. Then after everything is loaded, we go to the next scene. The next scene is the selection scene. In the selection scene, we create the list from the blockchain. We get a list of token IDs from the blockchain. With these token IDs, we create inside the game a list of playable NFTs the player will have. For this list, I created the script, the list manager, and the list manager will call the balance from the player, create a list of token IDs, after we call the web server, if we have these IDs, this means here you set your web server URL, in my case, there I stored the game data URI files because I built two URI files, one for the game data and one for the blockchain. So this list will call the data from the game data I created on the web server, call the information from the game data, and create an object with the strings and sprites and game objects we need that we can create the list. This goes to the next scene where the list is loaded later. From the scripts, now we have the balance script that's create the whole process during the login and everything. That's why we have to go back to the loading screen every time if we buy or upgrade a new NFT. The new NFT, when we buy, we have also these addresses to set. So there's the coin address we set. Then we have to set the NFT addresses too. This time we need the address for the game wallet. This can be found here. Then it's, for me, it's Binance. Testnet. Then this is the API code. If you write other functions to your smart contract, you may need to take your own API code. The API code can be found here. If you take the contract that you want to have and click after of API, then you get the API code from your own smart contract with other functions. And you can, this is a long code that you have to input, and you have to be sure that you have this slash with exclamation marks. So the rest is set up. Call method transfer means that we call a function in the Web3 application that MetaMask pops up and show us the amount that the player will spend to get the NFT. Then the buy functions are pretty easy. We have these strings. These strings get it in an object and sent to the E4M through the Web3GL contract script, WebGL script that is implemented in the Web3 folders that we can download from the GitHub. And I needed in order to get the same functions with two contracts with one click in the game, you need to make coroutines that we wait till the transaction is finished. After the transaction is finished, we wait till the blockchain is finished with writing the transactions. Maybe the block is deleted. It can be different times. I use 10 seconds, and every 10 15 NFT I will create is leaks. That means the NFT is created on the blockchain, but the token ID was not ready, and that's why the web server didn't create a JSON file. You can get a higher number, then you have to wait a little bit more during the process. And after this, we will get the latest token ID from the account and do a random NFT from the NFT list. In the NFT list, we also have to set the URLs for the game. So I will copy this. And this is where the URL from the games comes. And this is the NFT 721. And inside the NFT 721 folder on the web server, there are the JSON files stored. And the images get stored on the same place with image. So the random NFT generator, I just build a simple random NFT generator with just 1 to 5 number. This is not really much differences, but you get every time if you click, you have another NFT. Then I have to separate it every step that the blockchain not blocks the functions. And then we create a JSON file. These JSON files go to the server. There we have to set the URLs. So we call to server, take the JSON, make a request to the server. On the web server, we have the PHP script from Unity. With this script, it's be able to write a JSON file on the web server. This is not really safe. There you have to make a htaccess file where you get sure that only the application from your web server is able to write PHP files or JSON files to your server. The from Unity script is like this. They just get the token ID and the game data or the metadata and save it to this destination where you post this PHP file. So after we finish the creation, we go back to the place, buy or upgrade, and end the loading screen. So then I created this show NFTs with simple script. If you have balance bigger than this, the character is set active or false. Simple showing the NFTs inside the game from amount of balance. Then you show the account from the wallet, you show the balance and the NFT balance, everything to player breaths, because you can log off and in every time. So this information must not be stored for a long time. They delete every time if you finish the game or clean up the game. Then we have this selection script that adds these characters to the list. Depends on the balance of player or NFTs you have paid. So I just take a look, but I think we have set everything. So to get everything clear, which files we have to change. It's every file where you have in the upper something to change, and this should be. So you have to change to server, ERC721 list, buy, from server, balance, and upgrade. I'm pretty sure upgrade needs something else. Yeah, in upgrade you need the same information like buy. So I just do like this. Then it's the chain Binance, and I'm on the test network. Then the functions are called upgrade. There's we get the token ID from the player choose selection, send it to the blockchain, wait till the blockchains accept the payment. If the payment is done, we come back, start the NFT process from minting and burning. So after we set up these 6 scripts inside the game, we are now able to communicate with the blockchain. And as I said before, if you use the web dev script and fill inside the web dev script the same wallet address you used to deploy or used to buy NFTs, you can go to the scenes, loading screen, and then you can see and watch if the game loads. I have no debug information or something else. Yeah, it was, I should have pushed the button save. After I pushed the button save, it's working like as I expected it should work. So now we see I have these 3 NFTs, and I see that the token ID is 30, the name of the NFT, the account that owns the NFT, and where inside the game is the sprite and the prefab or game object saved. With this information, we create this list where we see the NFTs and where we can go inside. Now we see I have 8 NFTs, 4. When I look, I have ERC1155 NFTs, 8 pieces. So we see that everything works fine. We should not push the button pay because we are not able to call MetaMask inside from Unity. This is only able inside the Web3 application or web server. So to deploy the game on the web server, you should check the network script. Here you can choose which network the game should be run on the web server. I hope you enjoyed the tutorial. Nice day.